Hey everyone, so here we are with 10.5, which is titled Permutations and Combinations. We're just going to be here looking at number of ways we can pick and choose something. We're also going to be looking at what's called the binomial theorem and expanding binomials here at the end of the lesson. First, let's look at a little quick cartoon of the day. In the bleachers is here. Is it safe to look, sire? There's a timeout on the battlefield. Our athletic trainer is taping up Sir Dwayne's twisted ankle. Always a fun in the bleachers. Okay, so let's first look at permutations, which is on page 305 in your vocabulary. This is what you want to write for permutations. It's an arrangement of objects in which order is important. And that's really the main thing. Order is important. So here's an example of, let's say, books. Here you have some books. How many ways can 8 books be arranged on a bookshelf? And you can write this down and underline that. You can just say 8 books be arranged on a bookshelf. Here's what we want to do for that. We'd want to write down, it says reason it out with slots. So we want to write down 8 different slots that we would fill these books in with. So you can first, write that down, and then right underneath that, just put down 8 little spaces here, 1, 2, 3, 4, 5, 6, 7, 8 little slots there. And then as we start to reason this out, we would say, okay, for the first slot right here, you have 8 books to choose from, so there's 8 ways to choose for that first slot. But then for the second slot, now there's only 7 books left, so only 7 ways to do that. And we're going to be multiplying all these number of ways together, so 8 times 7. And then for the third slot, now there's only 6 books to choose from or pick from, so there's 6 there, and then it just keeps dropping down. 5, then times 4, times 3, times 2, times 1. And so we would multiply all that together. You could do that on a calculator. I'm not going to show you that just to save some time, but you can multiply that all together, and that would give you the number of ways, 40,320 ways that you can arrange 8 books on a bookshelf. Now this next one here says, you have those 8 books, so you can write down again 8 books, but you can only put 3 of them on the shelf. So you only have space for 3. So now what do we do? Well, now we only have 3 slots. And so we could do the same thing with the slots. Just put only 3 down. You only have 3 spaces. But we have 8 books to pick from. So that first slot, there is 8 books to pick from. So 8 possible ways to do that one. But now there's only 7 on the next one. So then times 7. And the last one, there's only 6 on that last one then. So there's just 8 times 7 times 6. And that's what we would multiply together there, and we would see how many ways that is. That's 336 ways for that. So for permutations, the main thing here is you need to realize that order matters. The order that these are in definitely does matter. You can't just throw them. It's going to be an arrangement. You're arranging them in order. So like on a bookshelf, they're going to be in order. It's not just a bunch of books lying on the floor. They're in order. There's an arrangement to this. So make sure you write down order matters for permutation. Okay, so let's go to our extra practice, page 307, and try a couple of these. It says here, find the number of ways you can arrange. And that's a key word right there. When it says arrange, you know you're talking about a permutation and not a combination. When we get to combinations, we'll see we're not going to use the word arrange. It's only for permutation because there's going to be an arrangement. Order's mattering. For this one, we're going to find the number of ways you can arrange A, all the numbers, and B, only 3 of the numbers in the given amount. So kind of just like those books we were talking about. So in problem 1, how many numbers do we have here? Well, there's 7 numbers. We want to arrange them in order. So for this one, we're going to start out with just 7 slots then. We're going to use all the numbers. So 7 slots. And for the first slot, there is 7 numbers then to pick from. And then for the second slot, there's only 6 now, and it just keeps dropping down 1 after that, times 5, times 4, times 3, times 2, times 1, and you'd use your calculator just to multiply all that together, and when you do that, you'll find the number of ways. So this would be 5,040 ways to do that. Letter B, we want to just do 3 slots on letter B, because we're just going to just pick 3 of the numbers. So only 3 of them would just really be these first 3 right here. So 7, 6, and 5, that's all there's going to be there. 7 times 6 times 5. And when you multiply 7 times 6 times 5 together, you can use your calculator. It's just 210 ways for that one. Go ahead and then stop the video, pause the video real quick, and try number 2. Do the same thing for number 2. You have a few more numbers on this one, but it's done the same way. Alright, so hopefully you've done number 2 and you got a couple answers for that. So number 2, we have, looks like we have 10 numbers here in this number here. So we want 10 slots. So for letter A, we're going to put down 10 slots here. For the first slot, there is 10 numbers to pick from. Then the second slot, there's 9. Then there's 8, 7, and keep going down to 6, 5, 4, 3, 2, 1, all the way to that last one. There's only one number left for that last slot. It's going to go there. So when you multiply all of those numbers together, we'll get our answer for this one, which is going to be 3,628,800 ways to arrange these 10 numbers. And then if we only choose 3 of them, it's really just going to be the top 3 right here. So you're going to just have 3 slots. It's going to be the 10, the 9, and the 8. So you have the 10 numbers to pick from, then 9 numbers, and then 8 numbers, and then just multiply those 3 together to get our number of ways, 720 ways. So hopefully you got those answers right, and you can now start understanding a little bit about permutations. Okay, so back on page 305 on the vocabulary, it says n factorials, and so we want to just write this down. What is a factorial? Factorial is kind of what we were just doing when we take a number, kind of like what we see here. So there's 5, 4, 3, 2, 1. We multiplied all those together, we get 120. Well, we can have a notation for that, and that's using the number 5, the top number there, the first one, and then putting an exclamation point next to it. And that exclamation point is actually called factorial. This would be 5 factorial. And so when you see that, you know you're just going to do this. 5 times 4 times 3 times 2 times 1, and that would be that number 120. So you can write down next to your vocabulary, you can write n factorial with n with an exclamation point. That's the notation. N would just be the number that you would have. Here's a bunch of other examples. Why don't you go ahead and write down this one here with 5. You can say 5 with the exclamation point equals 5 times 4 times 3 times 2 times 1, and it equals 120. Here's another thing you can do, the definition, the official definition, and if you want to write this one down, you can. Basically, it's whatever the n is going to be your first number, and then minus 1, take 1 away from it, it's going to be the second one, minus 2, minus 3, and so on, all the way until you get down to it's going to be 3, 2, 1 at the very end, like it is here. You don't have to write this one down, but as long as you write down what's here, n with the exclamation point, and then at least this example here. A couple things else about it. It says n cannot be a decimal or a fraction. Say that's got to be just a regular whole number like that. It can't be a radical or even a negative number. It has to be a whole number. And that's why you want to write this down also. So make sure you write down that n has to be a whole number. So you can write down n factorial and then that part right there, that n must be a whole number for the factorials. And this little piece of information that if you ever see 0 factorial, and you might not see it very often, you're not going to see it in this lesson, but if you see a 0 factorial, it does equal 1, it doesn't equal 0. So that's something to realize. 0 factorial equals 1. It's kind of like something to the 0 power is equal to 1, so it's kind of similar to that. Okay, so also right there on that same page where the factorials are, here's a couple more I want you to write down. Do a couple of these examples. You can just write this down with 5 factorial over 2 factorial times 3 factorial. When you see factorials next to each other like this, it just means they're multiplying each other. And so here's what we could do. We could start with 5 factorial and go 5, 4, 3, but we'd want to stop at 3 factorial because we have a 3 factorial on the bottom here in that purple. And what you're seeing here is you can cross out a factorial with the same factorial. So 3 factorial can cross out with 3 factorial on the bottom, and that just makes it a little easier. Now you just can see you're going to have 20 on the top and 2 on the bottom, which would then just reduce down to 10. So go ahead and write that example down. Here's another example that you could see. You don't have to write this one down necessarily, but you can watch it. See, here's 8 factorial all the way down to 1, 5 factorial all the way to 1, and they crossed out 1 for 1, 2 for 2, 3, 3, 4, 4, 5, 5. And now they just have left 8, 7, and 6, giving them that 336. What they could have done, though, is they could have gone down to just 5 factorial and stopped there like we did up here. And they could have crossed out the 5 factorial with the 5 factorial on the bottom, leaving them just with the 8, 7, and 6, and that might have been a little easier. Okay, so on the core concept for permutations, just right there at the bottom of that page, you can see that there's a notation for this using P for permutations, or you can also consider it as like picking. You're going to pick something. So you have the two numbers here. You have a first number and a second number. If those two numbers are the same, it's just going to be that number factorial. So like here's an example of that. They're both the same. They're both 4, so it's just 4 factorial, which is 4, 3, 2, 1, giving them 24. So basically what this is saying is that you have the number of permutations of 4 objects. So you have 4, and you're going to pick all 4. It's kind of like when we did that arrangement of the books, and we say we're going to, we have 8 books. We're going to put all 8 books on the shelf. So this is always the number that you have here, and this is the number that you're going to arrange. So you have 4. You're going to arrange all 4. So that just is a 4 factorial. But if those numbers are different, so now you have an N and an R, so this is the one you usually see right here, NPR. If those numbers are different, like this one right here, 4, you have 4 objects, books, or whatever it is, and you're going to take or pick 2 of them to arrange. Then that's going to be a little bit different. You're going to have this little formula here where it's n factorial on top and then n minus r factorial on the bottom. So your n factorial would just be that first number, that's the 4 on this one, and then 4 minus 2 would be 2 factorial, that's going to be on the bottom, and then that could cross out there with those 2 factorials, and you just have the 12. Alright, so I have a quick little song to kind of help you with this. So that's what permutations are, as it said there, and hopefully that helped a little bit to make that a little more clear. Let's go ahead and to our extra practice and now try a couple. Okay, so problem 3 on their extra practice says your rock band has 9 songs recorded, but you only want to put 5 of them on your demo CD to hand out to local radio stations. How many possible ways could the 5 songs be ordered on your demo CD? So definitely the wording is definitely permutation. It says ordered right here. You're going to order them. It's an arrangement. There's going to be an order here, so order does matter, which means it's definitely a permutation. So we can say, well, how many songs we have? We have 9 songs, so that's what we have. How many are we going to put on the CD? We're going to only put 5 of them. So your notation for this would be 9P for permutation or picking 5. You have 9, but you're going to pick 5. That's kind of what you think of it as. P kind of stands for almost like the picking 9, picking 5. And so if that's the case, then we're going to say 9 factorial is going to be on the top for the formula, right? It's always the 9, always that first one, factorial on the top, and then you subtract these two for the bottom factorial. 9 minus 5 factorial is on the bottom, which ends up being 4 right there. 9 minus 5 is 4. So it's 9 factorial over 4 factorial. And then we can start to, write this out, starting with 9 on the top, times 8, times 7, times 6. You just keep going until you get to 4 factorial, and then you stop, and then you can write the 4 factorial on the bottom and cross those out. And so now all that's left then is to multiply 9 times 8 times 7 times 6 times 5, and that would give you your answer here. And it should be this many ways, 15,120 ways to do that. Now number 4 is a little bit different. It's actually talking about probability. It says find the probability. So we're going to link this permutation with probability now, which remember probability is always your favorable outcomes over your number possible outcomes. Favorable always over possible. And so it says here, a witness at the scene of a hit and run accident saw that a car that caused the accident had a license plate with only the letters I, R, L, T, O, and A. find the probability that the license plate starts with a T and ends with an R. So the number of possible outcomes there, the possible ways, is that there are 6 letters to choose from. 6 letters here kind of to pick from. So the number possible would be 6 factorial. To arrange it. How many ways could we arrange this? Well, there's 6 letters total. So that's your total number, is 6 factorial. The favorable would be, what we want is with a T to start and the R to end. So it would be like this, with T on the first one, R on the last one, and then the 4 middle ones. It doesn't, the numbers here or the letters here could be any letters, but we definitely want T first and R second, so those are locked in. So what's kind of what we want to think here is that there's 4 to pick from here. So for this one, there's 4 letters left. Then there's 3 letters left, 2 letters left, 1 letter left. That's a 4 factorial right there. So the favorable is 4 factorial. So it's always favorable over possible. The P for probability is always favorable over possible. So it's going to be 4 factorial over 6 factorial. And then we can write out the 6 factorial down to where it says 6, 5, and then 4 factorial, where we can cross out the 4 factorials. So 6 is always obviously more, so we want to start with that one. 6 times 5 times 4 factorial and cross those out. That leaves you still with a 1 on the top though. If you cross out a 4 factorial, you still have 1 on the top, and then 30 down here, because 6 times 5 is 30, so 1 in 30 is our probability. Or the decimal form of that would be 0.033, or the percent form would be 3.33% chance of that happening. Okay, so now we switch gears a little bit and go to the other type of one here. We talked about permutations already. Well, now the second one is combinations. These are very similar to each other. It's kind of like a little bit of an opposite thing going on here. What you want to write down on page 305 in the vocabulary for combination is right here. It's a selection of objects in which order does not matter. So really the only difference there is that word not. Order does not matter. And so what we want to realize here is permutation. If I said, okay, there's that same one we talked about before, you're going to arrange the 3 books on the shelf. You have 8, you're going to arrange 3 of them. We already saw that. That was 336 ways. That was this formula right here. Well, now we have a very similar one. We have 8 books, and you're going to still use 3, but you're not going to arrange them. This does not say arrange. Instead, it says that you're going to take 3 on vacation. So there's no arrangement, as you maybe put these in your backpack or your suitcase as you pack. So there's no arrangement happening. So if there's no arrangement, then it doesn't matter the order that they go in. There is no order. One can be on top, one can be maybe underneath your socks, the other one can be, stuffed somewhere else. So it doesn't matter the order. So in that case, what we're going to see here is we're going to, we're going to take this down. We're going to take what we had here, the 8 factorial over the 5 factorial. That was the permutation. We're going to divide out the arrangement. The arrangement is the 3 factorial. That's the arrangement. So we're going to divide that out. So we're going to take that answer, 336, divide it by 3 factorial. That gives us 56. Notice the combination number is much smaller than the permutation number, which will always be the case. And here it says, what's the difference between these problems? Well, order doesn't matter. And that's what you want to make sure you write down for combination, that order, it doesn't matter. Permutation, order does, and combination, the order doesn't matter. Our core concept for this one, you can see here, you're just using C instead of P. Same kind of notation, NCR. And so you have this many, you're going to choose this many. I usually think of C as you're going to choose them. So N choosing R. And so you can see the formula for this starts with the n factorial, just like the permutation did. It has the n minus r factorial, just like the permutation did, but there's one addition. There's an addition of the r factorial down at the bottom. So that's where you're dividing out the arrangement. So if I say again C or 4 choosing 2, you have 4, you're going to choose 2. 4 factorial on the top, there's that 4 minus 2, which is 2 factorial, but then you also have the 2 factorial from what r is here. And so that means you're going to get a lot less number than that we had on the first core concept. You can kind of check that to make sure that's true. So you have the combination. It's going to use the word combination or something like that. It's just not going to use the word arrangement. It's not going to use the word order on this one at all. So here's another little snippet of that same video, but now with the combinations. Okay, so hopefully that helped you understand what combinations are a little bit. I'm going to show you just a few different situations of combinations. This first one is, now you don't have to write this one down, you can just watch. It just says you have 105 employees and you need to select a committee of 3. How many ways can you do it? And you want to always ask yourself, the question is, does order matter? Because if order matters, then you know you're working with a permutation. If it doesn't matter, then you're working with a combination. So in this case, no, order doesn't matter in this one. You're just selecting a committee. You're not going to assign any positions on the committee. Like, you're not going to assign a recorder, and then somebody else is going to do this. There's no assignments here. You're just picking a committee of 3 people, and so you're using that formula then. So you have 105. You're going to choose 3. So there's the 105 factorial. 105 minus 3 factorial. That would be what the part of that permutation. But you have to divide out the arrangement because we are not doing a permutation. We're doing a combination. And then it just shows you how you would do that with the factorials here. Again, you're taking, since it's such a big factorial, and you have 102 factorial here, you only need to go down that far to 102 factorial, so you can cross those out. And now you have these 3 big numbers to multiply. You have 3 factorial, which is 321. Now you can do this, I might just go ahead and multiply all this on the top and then have 6 on the bottom and then divide that big number by 6. That's probably the way I would have just done it on the calculator a little quicker. But you can do this. You can say 3 goes into 105 35 times, 2 into this one 52 times. That way it kind of gets rid of those numbers down there. Here's another one. Okay, this one says you order a sandwich at a restaurant. You can choose 2 side dishes from a list of 8. How many combinations of side dishes are possible? And notice what they use. They use the word combinations right there. So that's a clue that you're doing a combination and not a permutation. And so for this one, I'd like you to write down just right there on page 306, probably right next to that combination core concept. Just write this down here, 8 choosing 2. Just write that down right now. And I'm going to show you one way to do it with the factorials. And this is what they're doing here using the formula. There's your n factorial, n minus r. There's your arrangement you're dividing out. So they're doing that, and they're simplifying this whole thing, getting it down to 6 factorials which you can cross out. So now you have basically 56 divided by 2, which is 28. I wanted to show you another way you can do this, though, with slots. Remember we talked about the slots before. So if you're picking 2, so you have 2 slots. You have 8 to choose from, but you're only going to choose 2. So you're only going to put 2 slots down. And what you could do for that first one, you have 8 to choose from in the first slot, 7 to choose from in the second slot, so 8 times 7 is the 56. But then you want to remember this is a combination. This would be the answer to a permutation if their order did matter. But since it's a combination, we would want to then divide out the arrangement, which is the r factorial, which is here 2 factorial. In that case, it's 2 times 1, which is just 2. So 56 divided by 2 is 28. You can go ahead and write that down. That's one way we can do them as well, is using the slots as well. Just have to remember, if it's a combination, you're going to divide out the arrangement, the r factorial. Okay, so back to our extra practice, page 307, number 5. It says how many possible combinations, and so there it gives you the way right there. It's a combination. We're not doing a permutation. So many possible combinations of 3 colors can be chosen from the 7 colors of the rainbow. So we have 7, but we're going to choose 3 of them. So we're going to choose 3. So we want to write that as a notation. Go ahead and write it down like this, with 7 choosing 3. 7C3. 7 you have. This is always the first number is what you have. You're going to choose 3 of them. So it starts off with the 7 factorial on the top of the fraction, and then you're going to subtract these two. 7 minus 3 factorial next to that on the bottom. That would be, if it was a permutation, you'd stop there, but because it's a combination, we have to do one more little part of the 3 factorial. We got to divide out the arrangement, which is another r factorial. And so now as we do this, this is going to end up being 4 factorial right here. So we're going to put down 7 factorial, so we'll start with 7 times 6 times 5 times 4 factorial. We'll stop there because this is 4 factorial here, which if we put that down below, we can then cross out our 4 factorials. And then the 3 factorial, we'll do 3 times 2 times 1. And 3 times 2 is 6. We can cross both of those out with the 6 above it. So just a little quick cross canceling. What we have left now is 7 times 5 on the top and just 1 on the bottom. So the answer is just 7 times 5, which is 35. So there's 35 ways in which that's possible. If we wanted to use the slots, remember, so that was one way of doing it where we could use the factorials. If we wanted to use the slots, we have 3 slots to choose from. We're just going to say we have 7, 6, and 5 for those 3 slots. We could do it this way and then figure out, okay, what that is. As we multiply that out, divide that by 6, which is 3 factorial. Right, so we're going to divide out by 3 factorial. We can cross out the 6's there, and now you can just see still 7 times 5 is 35. So you could have done it just as easily with using the slots. Okay, just 2 more examples I wanted to go over. This has kind of the similar feel to it, but one's a permutation and one's a combination. So for the top one, I want you to do this one on the middle of page 306, just right underneath the core concept for combinations. For this one, it says there are 15 kids, and you need to pick 9 of them to help you TP a house. How many ways can you do it? Now, for this one, it doesn't give you really a lot of clues as to if it's a permutation or combination. So you definitely want to ask yourself the question, does order matter? And so in this case, does order matter here? You're just picking 9 people to go help you TP a house. Of course, order doesn't matter. Doesn't matter the order in which you hand them the roll of toilet paper or anything. So this would definitely be a combination. So you'd want to write it down as 15. You have 15. You're choosing 9. And so you start with 15 factorial on the top. If you subtract these 2 numbers, you're going to end up with 6 factorial, and then you got to divide out the arrangement because it's a combination of 9 factorial. So we start to run this down here with 15 all the way down to the bigger one, which is 9 factorial. So 15 all the way down to 10, so 14, 13, 12, 11, 10, and then we got to put 9 factorial, and then on the bottom we have this 9 factorial that we can cross out with that. But then we still have 6 factorial here, which we want to run that down, 6, 5, 4, 3, 2, 1. And now we could just start crossing out of the things. So we could start crossing numbers out here, 5, and 2. 5 times 2 is 10. We can cross out the 10 with 5 times 2. 4 times 3 is 12. We can cross out the 12 with that one. The 6, we could even break that up into 3 and 2. And 3 goes into 15. 5 times, so we can make that a 5, and 2 goes into 14 7 times, we can make that a 7. So we can just start just simplifying as much as we can. So now we have 5 times 7 times 13 times 11 on the top, and everything's been crossed out except 1, so it's just over 1. So it's 35 from 5 times 7 times the 13 times the 11, multiply that on the calculator, and we would get 5,005. So there's 5,005 ways to do that. Then right there on the bottom of 305, so turn back a page underneath the permutation one. This one says there are 15 kids and you need to pick 9 to form a softball team. You will be assigning positions. How many ways can you do it? So right there a clue is that you're assigning positions, which means there's definitely an arrangement. One of them is going to be pitcher, another one's going to be catcher, first base, second base, and so on. So this one definitely would be a permutation. So you have 15, you are picking 9 with a permutation. So 15 factorial on the top, and then 15 minus 9, which was 6 factorial on the bottom. So you can take the 15 here all the way down to 6. So you're going to do this one all the way down here to 6. So that's got 987, and the next one would be your 6 factorial. And you can cross that out with the 6 factorial on the bottom. So now you just got to multiply all these numbers together 15, 14, 13, all the way down to 7 on your calculator, and that would tell you you have a lot. This would be 1,816,214,400 ways to do that. So that would be your answer for this one. Alright, so let's go on to one more part, which is the binomial theorem and expansion. But before we get to that, let's do a quick little joke of the day. Why was 6 afraid of 7? Well, because 7, 8, 9. Maybe you've heard that one before. Okay, so for the binomial theorem, I'm not going to spend a lot of time on this because I have done this in a previous lesson. I think it was in chapter 4 that this was also in. There's a little bit more to it this time now, but this is kind of a little bit of a review from what we saw in chapter 4. Basically, you have a binomial to an exponent that's pretty big, like this one says 6. You start, number 1, you start with the first term in that binomial, and it's going to be at that number there, 6, a to that 6th power, so this term to the 6th power. And then that just keeps dropping down once, and then it's 5, kind of like the factorials, 5, 4, 3, 2, 1, and eventually the last one. So this would be a to the first, this would be a to the 0 power, which would be 1, that's why you don't see the a in there. The second term in the binomial starts off at 0 and then goes up 1. So that's why you don't see it in the first term, because b to the 0 would be 1. But then b to the first is now here, and then b to the second, third, fourth, fifth, and all the way to the end there, b to the 6th. And then as far as the these a, b, so basically the powers on these should always add up to 6. That's another thing it says right there. Those are always adding up to 6, the same number. And then the coefficients, these numbers, we talked about how we could use a triangle to help us figure that out, called the Pascal's triangle. So here's the triangle for that Pascal's triangle. You can just generate that triangle very quickly by just having the 3 1s there, 1 and then 2 1s below it, and then each one of these you're going to just add these 2 numbers to get the number below that, and then always start and end each row with a 1, and then these 2 numbers would add to get you the 3, and another 3, start and end that row with the 1s. And so that's what the numbers that you see from this page over here, these green numbers here, 1, 6, 15, 20, 15, 6, and then another 1, this would be. It's because you're looking at the 6th one here. So that's where you see, okay, a to the, the exponent of 6, that's the very last one. So there's those numbers. You're using these 7 numbers. It tells you have 7 terms. You're always going to have one more term than what the exponent says. So if it's got a 6, then we had 7 terms. Now as far as this goes, you can see how we're using combinations. It's another way we can do it, and I'll talk about that in a little bit, but we can use combinations to be able to help us figure them out as well. In fact, each term you can see right here, this is maybe an important part to highlight. You can go and highlight this one. Each term of this expansion has the form of the combination NCR and then A of N minus R up on top here, B of the R. And so that's where you're at with this. We'll go and look at this a little bit more in just a minute. Here, I'll show you this page here just to show you how the Pascal's triangle here can relate to the combinations. So if you have this would be the exponents here, the n would be the exponent, so a 0 exponent, 1, 2, 3 exponent. You could see that would be the 1, so anything to the 0 power is just 1. If it's to the first, it would just be what that binomial is. If it's to the 2nd power, now you have 3 terms in there. And you can see how the combinations work here. So this would be 0 and you choosing 0. So 0, 0 here would just be 1. And this would be, you have 1, you're going to choose 0 for the first one, then 1 and 1 on the next one, 2, then it's going to be, the R just keeps on going up 1 each time. So the n stays the same. So on row 2 here, when your exponent's 2, that's going to be your n. But then the first one here is going to be 0, 1, and 2, and so on. That's one way you can do it to figure out what these numbers are as well. Instead of having to generate the whole triangle, you could just do it with the combinations. For me, it just is easy enough to do it with a triangle because I can generate that pretty fast. So it really isn't too much trouble. There's just a few different other ways that you might see the notations written out. Sometimes they're written like this, where n is on top and r is on the bottom. That's just a notation. So I'll show you this. This is just kind of comparing the 2 different ways where you can either use combinations, or if we just use the Pascal triangle, so you could start with this, so you have the exponent of 3, so again that's n and then your r, so 3, and then 0, 3 and 1, 3 and 2, 3 and 3 for each term. You can see there's your x's going down 1 each time, your y's are going up 1 each time, and then these become the factorials here. You can see 3 factorial over 3, so a combination. But for me, it's just more work to do this than just to quickly do the triangle, because we could do that triangle and get, really it's the one with the 4 numbers in it. It's a 1, 3, 3, 1, and you can see right there 1, 3, 3, 1. I already know it's 1, 3, 3, 1 from the triangle, so I really don't use this very often to do these binomial theorems. Okay, so for number 6 on the extra practice, it says use the binomial theorem to write the binomial expansion, and the binomial is 2x to the 4th plus y to the 3rd, and it's raised to the 3rd power up here. So basically there's 3 of these. We could put them all side by side if we want to. We could even multiply these long ways if we wanted to. That's another way you can do this. If we saw 3 binomials, exactly this, 2x to the 4th plus y to the 3rd, 3 of those, we could do 2 at a time with FOIL, and then another 2, with like a double distributive property. So that is another way you can actually do this, especially when the exponent's only like a 3. When it gets to be maybe a 5, that might be a little harder. But that's kind of the long way of doing it, I suppose. But this also takes a little bit of time itself. So first thing we need to know is what's the Pascal triangle going to be for 3. So again, I could use the combinations. I don't usually do that when I'm actually going to expand it out, because I usually just make sure I get my 3 1s there. Then the Pascal triangle, the next row is 1, 2, 1. And so this is when exponent is 0, exponent is 1 here, exponent is 2, exponent is 3. I know there's going to be 4 numbers or 4 terms in this because the exponent's 3 here. So my 4th one with 4 numbers in it is going to be that one, 1, 3, 3, 1. Those are the Pascal numbers I got to use. Now you can see there's number 8 down here. We actually don't have an 8 or even a 7 on the extra practice. This is going to be another problem that we're going to put on the bottom of 306. And we're going to be doing this one. We're going to expand out just x plus 3 to the 5th power. And for this one, we would need actually the row with 6 numbers in it. So that's 2 more after this one. So I would need generate the next row. Adding and getting 4, adding and getting 6, adding and getting 4, put the 1s on the ends, and then get the 1 more row for actually this problem down here. And we would get 1, 5, 10, 10, 5, and 1. Again, just adding to get 5, adding there to get 10, add again to get 10, add to get 5, 1s on each end. And so those are your 6 numbers to use for this one. But let's concentrate now on number 6. We're going to use just these 4 numbers here for number 6. 1, 3, 3, 1. So we're going to start with the Pascal number, which is 1. So we'll put that down first. And then we have our first term here, the first part of the binomial, the 2x to the 4th. We're going to raise that to the 3rd power. So it's always going to start with the power it gives us. And then for this term, the second term, y to the 3rd, we're going to raise that to the 0 power. So that was to the 0 power. Then we're going to put plus the next term, plus the next Pascal number, which in this case is 3. So plus 3. And then this term will now be raised to the 2nd power, which is 1 less there. So you drop that one down by 1. So that same term just raised the 2nd. And then this same term, y to the 3rd, will get raised up to a 1. So from 0, this goes up to 1. So y to the 3rd to the 1st. Then plus the next Pascal number, which is 3 again. So plus 3. Our 2x to the 4th is now going to be raised to the 1st power, and the y to the 3rd is now going to be raised to the 2nd power. And then our last Pascal number, which is 1, so plus 1. And our first term, 2x to the 4th, is now raised to the 0 power, and the y to the 3rd is raised to the 3rd power. Okay, so that's everything laid out. We just now need to clean this up. So we have some powers we need to do here. So this 1's not affected right now, but we're going to need to figure out what this term really is. We're going to raise 2 to the 3rd power, which is going to be 8, and then you're going to multiply the exponents here. That's going to give you 12. So we start off with the 1. That doesn't change, but now this is going to be an 8x to the 12th power with 4 times 3. And then this one, anything to the 0 power is always 1, so that's just going to be a 1 right there. And then plus the next Pascal number, which is 3. We won't change that one yet. We'll be multiplying eventually these Pascal numbers in. But here we have a 2x to the 4th raised to the 2nd, so we're going to say 2 squared, which is going to give us a 4 for the big number, and then multiply the exponents. 4 times 2 is 8, so it's going to be a 4x to the 8th power. This one, 3 times 1 is still just 3, so y to the 3rd on that one. Plus that next Pascal number of 3, And this one is going to be 2 to the first is still 2, and this will be still 4. So this is going to be the 2x to the 4th right there. And then this one is going to be 3 times 2, which is going to be y to the 6th. And then plus that last Pascal number. This will be to the 0 power, so that would change that into a 1. And then 3 times 3 for those exponents, that's going to make that y to the 9th. So we are almost done here. We still got to clean it up one more time to just get these all, multiply these 3 terms together. 1 times 8x squared, 8x to the 12th times 1 is just 8x to the 12th there. So we have the 8 and our x to the 12th. And then it's going to be plus the next term here. So this one we want to multiply 3 times 4. So multiply the big numbers, which will be plus 12. And then you'll have a y to the 8th and an x to the 8th and a y to the 3rd. So x to the 8th is there and y to the 3rd is there. And then it's plus the next big number here, which will be 3 times 2. So it's going to be plus 6. X to the 4th, y to the 6th will be right behind that. And then plus this one will be just 1, y to the 9th. So it's just going to be plus the y to the 9th, and then that is the answer. There's the expansion there. All right, so over on the bottom of page 306, go ahead and write this one down, x plus 3 to the 5th power. We're going to expand this one using these 6 Pascal numbers. So I'll write those down here, 1, 5, 10, 10, 5, and 1. Those are the numbers we want to use. So for our first term, we're going to use the first Pascal number, which is 1. And then our first term in here is x, so it's x to the 5th power, so time x to the 5th. This will be 3 to the 0 power. So the second term there in this binomial is 3, and you're going to raise it to the 0 power. So always, remember these always are going to add up to 5. Just like up here, the exponents here, 3 and 0, should always add up to the number here, 3. So we add the next Pascal number, plus 5. It's going to be x to the 4th power now. That's going to drop down 1 each time, and it'll be 3 to the 1st power. That will go up 1 each time. And then plus the next Pascal number, which is plus 10. And now it will be x to the, not the 4th, but the 3rd power. So it goes down by 1, and 3 will go up 1 to go 3 squared. Then the next Pascal number is also another 10. X to the 2nd power, it's going down by 1s. And then the 3 goes up by 1, so it's 3 to the 3rd. And then plus the next Pascal number is plus 5. And x is now to the 1st power, and 3 is now to the 4th power. And your last Pascal number, which is 1, x is now to the 0 power, and the 3 is now to the 5th power. So that's everything laid out. Now we just need to clean up each one and multiply this together. So this will be a 1 times x to the 5th times 1, because 3 to the 0 power is 1. So this is just going to be x to the 5th right there. So that's going to be a 1 there. So that means that's just going to be x to the 5th. 1 times 1x to the 5th is just x to the 5th. This one here, 3 to the 1st, is 3. So we're going to need to multiply 5 times 3 and get 15. So this is going to end up being plus 15x to the 4th. Here we'll see 3 squared. So 3 squared we know is 9. So it's going to be 10 times 9, which is going to give us 90x to the 3rd on this one. And our next one, 3 to the 3rd, is 27. So 10 times 27 is 270 x squared. 3 to the 4th is 81. 5 times 81. Multiply those together. We're going to see it's 405 x to the 1st, which is just x. And then 3 to the 5th power, that's, I believe, 243. And so this is going to be x to the 0 is 1 as well. So it's just 1 times 243. So it's just 243 at the end. And then that's our answer. So that's our expansion. So using Pascal triangle, for me, I think that's going to be just the easiest and fastest way to do these, and not using necessarily combinations for this. But there are specific times where combinations can be useful, and let's look at a couple where we'll see that. We're going to also go back to write these in, because there's no extra practice problems left, but we have a couple more problems to do. Okay, so here's a quick example of what I'm talking about. It says you want to find the 13th term of an expansion, like a plus b to the 15th power. So without doing everything we just did, we can actually just generate that one term. So here's what we can do. We can start off by looking at let's think about it. The second variable, the b, okay, it would be b to the 0, goes up 1 each time. So it starts off with b to the 0. So by the time we get to that 13th term, it would be b to the 12th. Because the first term is b to the 0. And then 12 more after that will be b to the 12th. So we know it's going to be b to the 12th for that. So then we can say, all right, at that point, what would the exponent for a be if this is b to the 12th? We know these two have to add up to that exponent of 15. So that means a has to be 3. So far we know that now. A to the 3rd and then b to the 12th. And so now we can go ahead and put this into our combination. And remember, this is going to be, right here, we can put it in a combination. You have 15, n is 15, and you're looking for the 12th number here because this is always r. The number that's on the b is always r. Remember we looked at that kind of Pascal chart before, and it always started with the 0 and then 1 for the r. So this would be our r here for the first term. On the 13th term, our r is 12. So it's going to be 12 there, so we can just plug that into this. 15 factorial. 15 minus 12 is 3 factorial, and then factored out that 3 factorial. And just work this out and get that it's 455 to complete that one term. So that's a lot faster than generating all of the terms and do the entire expansion. Okay, so still at the bottom of 306, if you still have some space there, you can put 9 and 10 in there. If not, then you flip back a page and see if you can find some space somewhere else to put 9 and 10, but write these down. So this one you want to say the coefficient, find the coefficient of x to the 5th in the expansion x minus 3 to the 7th. So it doesn't necessarily say find this term like that last example did. That's one example sometimes we might use. This one wants to know what's the coefficient going to be in front of this term of the x to the 5th term on this one. So here's where we can just figure out what that term's going to be. It's not always going to be the Pascal number because the Pascal number is the number we multiply terms together with. So we can't just look at the Pascal triangle to figure this out. This is where combinations does come in handy, and I already looked at this. This was from the core concept. You can see that right there on 306, I believe. So it says the a plus b to the n has the form of this combination, n choosing r, where your a term, your first term, is to the exponent n minus r, where the b1, the second one, is to the r. Now one thing about this is that when it does have a negative in here, this means your signs are going to alternate in your binomial. So the first term will be positive, then negative, then negative, and so on. So we can kind of see what this one's going to be. This is going to be our first term will be the x to the 7th, x to the 6th will be negative, x to the 5th will be positive. So we know we're going to have a positive number for this term. So the coefficient will definitely be positive. So let's start by plugging in what we know. So we know is that n is 7. That we know. This is always our n here, the exponent. So it's going to be 7 choosing r. The r is the one we don't know exactly, specifically on this one yet. But we're then going to say, okay, n minus r, so it's 7 minus r right there. So we have our x is the a term, so we're going to fill in the x, 7 minus r, and then b is 3 here, which really is negative 3. So we're going to put down that it's negative 3 to the r power. So we do need to make sure we put the negative sign in here for the 3, and that's the r power. So we need to figure out here, what's the r power going to be? That's what we're going to need to figure out then at this point. So right here it's going to be, you can see 7 choosing 2. Okay, so we're choosing 2. It's going to be 7 minus 5 is going to be 2. So that's what we're getting this. So our 5 here, we're going to go ahead and just subtract that to get the 2. So we know that these two, when you're subtracting, basically we know this term, this number right here, is got to be 5. So 7 minus r has got to equal 5. That means 7 minus 2 is r. So r has to be 2. That way that can be an x to the 5th power. And so that means that this is going to be negative 3 to the 2nd power on this one. That would tell us it's the 2nd power. And so now what we can do is we can do our combination with filling that out. So 7 factorial over 7 minus 2, which is 5 factorial, over 2 factorial, where we're dividing out that arrangement because it's a combination. And then we have x to the 5th term. We'll put that in there. So we need to figure out what this is first. So what is this number as we do this factorial? We're going to say 7, 6, and then stop at 5 factorial, so we can cancel out with that 5 factorial. So 7, 6, the 5 factorials now cancel there. And I'm going to do 2 times 1 is 2 factorial, and 2 can simplify with 6 here. I'm going to cross this out, and reduce 6 to be a 3. So now all that's left is 7 times 3, which is 21. So this here is 21. Basically, that would be your Pascal number. So your Pascal number is 21, and you're going to multiply that by negative 3 squared, which is 9. So when you do that, that's just going to be x to the 5th times 9. So 21 times 9 will give us our coefficient number. That's going to be 189. That's really the answer of this x to the 5th term. That's what they wanted to know, that the coefficient of the x to the 5th is 189. So this next one, same idea. We're trying to find the coefficient of the x to the 3rd term in this expansion where 8 is here. So we're going to do the same thing. We're going to see 8 and then CR. So 8 choosing R. We don't know what the R is just maybe quite yet. So 2x is our first term. That's going to be raised to the 8 minus R power. And then it's going to be the 5 is the second term, so 5 to the R power. So again, this power here from on the x has to be 3. So 8 minus what is going to be 3? Well, it's got to be 5. That means R has to be 5 in this one. So it's 8 choosing 5. And so now we're going to see 2x to the 3rd power there. We're going to see 5 to the 5th power there. And so now we got to do this 8 choosing 5 part here. So we're going to do it in our factorial. So 8 factorial on top. 8 minus 5 is 3 factorial. And then also that divide out the arrangement by the 5 factorial. We then now want to take this 8 factorial down to 5 factorial. So saying 8, 7, 6, then stop at 5 factorial. And that would then cross out with the 5 factorial that's below it. And then the 3 factorial, 3, 2, 1, you can say, well, that's going to actually equal 6, so you can cross out the 6, which just leaves you with 8 times 7, that's 56. So this whole thing, 8 choosing 5, is just the number 56. That is the Pascal number then as well there. You then want to now multiply here in, so 2 to the 3rd power would actually be 8x to the 3rd, so that second term is really 8x to the 3rd. 5 to the 5th power, when you multiply 5 times itself 5 times, that's 3,125. And so now you just want to use your calculator to multiply 56 times 8. So I'll do that real quick on this one. 56 times 8 times 3,125. And that whole thing equals this really big number here. It's like 1,400,000. So that's our coefficient. That's our answer for this one of the x to the 3rd term. All right, so that concludes our lesson here for 10.5. And so you want to get started on the assignment for this one, and I'll see you in class.